Imagine you are on a treasure hunt, and after months and months of searching, you have found the lost temple and can finally loot all of the treasure. But as you try to do that, you realize that the chest is behind a huge glass wall. To make matters worse, your arch rival is also there to grab the gold, and he has a giant rock to help him. You only have a marble in your pocket. What should you do to break the glass wall and take all of the treasure? Let's see your rival's plan. If he rolls the rock, the glass will easily break. Can you roll your marble and expect the same thing to happen? That might not work for you. But why? An obvious difference between the marble and the rock is that they have different sizes. To be precise, they have different masses. And the heavier rock is the one that is able to break the glass because it applies a larger force on the wall. What you've just figured out is that the force applied by an object depends on its mass. So using the rock, the glass will break easily and your rival might win. But now the pressure is on you. How can you break the glass with a marble? While thinking, suddenly you have an idea. You check your other pocket and find a toy gun. Would shooting the marble break the glass? This plan might definitely work. But why? Because now the marble would have a much greater speed. A greater speed will result in a greater force on the glass wall, and it would break. From this plan, you've realized one more important factor that affects the force applied by an object: its velocity. If you combine the two things you've just learned, you can say that the force applied by an object depends on its mass and its velocity. What you've just figured out, Newton had discovered a long time ago. He felt that if we combine mass and velocity, we can talk about force and actually calculate it. This gave birth to the concept of momentum. Momentum gives us a better idea about force. Let's see how. For an object with a mass m and velocity v, momentum is given simply as their product. We denote it by the letter P. So P is equal to mv. So the rock had more momentum because it had a greater mass. The marble had more momentum because of its higher velocity. And because of this large momentum, both were able to break the glass. We can use momentum to understand a lot of other things. For instance, ever wondered why a fast bowler takes such a long run-up when he bowls? Long run-ups help him gain velocity. What he's basically trying to do is gain momentum. This momentum helps him bowl faster. This same technique is used in many other sports like the javelin throw. The athletes take a run-up to gain momentum, and this helps them throw the javelin as far away as they can. Now that both you and your rival understand what momentum is and how it works, how about you both break the glass together and split the treasure equally, so everything's fair? I'm sure you're happy you learned these today. Force applied by an object depends on 1. The mass and 2. The velocity. P is equal to mv. Momentum equals mass into velocity. But you're probably happier because now you're rich, and maybe your rival will become your partner. In the next video, we'll take a deeper look at momentum, learn about its direction, and unlock a new adventure.